اوكي، السلام ورحمة الله. نبدأ بالحصة الثانية ب exercises. Exercise 4, we have chlorine is placed in row 3. Is the first information here in row 3 with 7 valence electron, and the chlorine element has two isotopes X and Y. The first isotope X has an atomic mass for the isotope X and 35U, and the atomic mass of the other isotope Y has an atomic mass 37U. Write with justification the electron configuration is then depending on row 3 and 7 valence electrons. Row 3 means that we have 3 occupied energy level, which are K, L, and M. 7 valence electrons. And we have 7 electrons in outer energy level. Then we have K2, L8, and M7. This is the electron configuration of the chlorine atom. We justify it by the following or as following: row 3 occupied energy level, 7 valence electron and 7 electrons in outer energy level. بآخر energy level عندي 7 electrons، يعني حيطلع معنا أنا energy level أو electron configuration is K2L8M7. Write the lowest dot symbol of chlorine. Chlorine is represented by Cl, and we have 7 valence electron. 1, 2, 3, 4, 5, 6, and 7. These are the 7 electrons in a chlorine atom in the outer energy level. Determine the composition. As we said previously in exercise 3, composition mean we have to find how many protons, how many electrons, and how many neutrons in each isotope. We have 2 isotopes of chlorine. The first isotopes, isotope X and isotope Y. Isotopes mean have same atomic number. Both of them have same atomic number. Is an isotopes, يعني they have same atomic number. Each one has an atomic number is equal to 17. Why it is 17? From the electron configuration, we have number of electrons is equal to 17, which is 2 plus 8 plus 7. 17 electrons. So, and since the atom is neutral, then number of electrons equal number of protons, equal to the atomic number Z is equal to 17. Then electrons is equal to 17 in each one, and the mass number is equal to 17. So the number of electrons is equal to 17 in each isotopes. 17 in X and Y. To find the number of neutrons, we have an atomic mass we have atomic mass is equal to 35U, the other with 37U. As we say previously, the atomic mass is the mass number with unit U. So the mass number is equal to 37 for the first, 35 for the first isotope, and we can deduce that the mass number of the second isotope Y is equal to 37Y. To find the number of neutrons, we find the number of neutrons from n equal A minus Z. 35 minus 17 is equal to 18. Is in our isotopes X and has 18 neutron. For the isotope Y, n equal 37 minus 17 is equal to 20 neutrons. This is the composition of each isotope X and Y. Write the atomic representation of each isotopes of X and Y. Since X and Y are isotopes of chlorine, meaning that we have both of them has a chemical symbol Cl. So Cl and Cl. Both of them have same atomic number 17. The first one has a mass number 35 and the other has a mass number 37. Okay, let's continue with exercise 5. Exercise 5. Write the electron configuration of the following ions. To write the electron configuration of the following ion, we must find the number of electrons. For aluminium ion is formed when an aluminium atom loses 3 electrons to become an aluminium ion. The aluminium atom has an atomic number Z is equal to 13. Since the atom is neutral, then number of electrons in aluminium atom equal number of protons is equal to Z is equal to 13. وجدنا عدد الإلكترونز بالألومنيوم atom هو equal to 13. To find how many electrons in aluminium atom الألومنيوم ion أو الألومنيوم atom loses 3 electrons. So number of electrons in Al3 plus ion is equal to 13 electrons in the atom minus 3 since it loses 3 electrons, so it has a 10 electron. To write the electron configuration of aluminium ion for the 10 electron K2 and L8. For sulfide ion, also by the same way, we have an atomic number 16. Z is equal to 16. Then number of electrons is equal also to 16. هيدي N sulfur atom before gaining electron. Before it gains electron, it has an atomic number 16. It has a 16 electron. Since sulfur is changed into sulfide ion, means that sulfur gain 2 electrons to become an anion sulfide ion. Since it gained electrons, so the number of electrons in the sulfide ion is equal to 16 plus 2 equal 18 electrons. To distribute these 18 electrons, we write K2, L8, and M8. The sum is an 18 electron. To write the electron configuration, shows that the atomic number of sodium is 11. Similarly, we have 10 electrons in the sodium ion. and the Na lose 1 electron to change into Na plus ion. We have an X electron of sodium minus 1 electron to have 10 electron in sodium ion. The number of electrons in sodium is X, so we find X is equal to 11 electron in sodium atom. And since atom is neutral, then number of protons equal number of electrons equal to 11. So this atomic number is equal to 11. بهالشكل أنا برهنت بعد ما طلعت إنه عندي 11 electrons، عندي 10 electrons in the sodium ion. We calculate the number of electrons in sodium atom as x minus 1 as a mathematical relation. X minus 1 equal to 10, so x equal 11. Find the number of valence electron. We write the electron configuration of sodium atom is in sodium atom. Since we have 11 electrons, the electron configuration is K2L8M1. The valence electron is the last electron in the outer energy level, so valence electron is equal to 1. The lowest dot symbol of sodium, we're sodium atom, and we put 1 dot. Also we can write it as sodium Na, and we write here the single dot electron or the 1 valence electron. The position of sodium atom in the periodic table, this means we must write or determine the row and column. Rho is equal to 3, and the 3 energy level and the energy levels that are K, L, and M, and he in column 1, then only 1 electrons in outer energy level. To write the equation of formation of this ion, sodium change into sodium ion by losing 1 electron. This is the last exercise in this period, and goodbye.